Good morning or good afternoon, depending on where you are in the world. I would like to thank Mark Lugetbuehl and the board members for establishing PEth-NET and the 2021 Spring PEth-NET meeting. I'm quite excited about this project. My name is Nathalie Hill-Kapturczak, and I'm at the University of Texas Health Science Center at San Antonio, Texas, USA, and I work with a group of scientists that are passionate about phosphatidylethanol, as will be discussed in more detail by Drs. Martin Javers and John Roach later today or tonight, depending on where you are located. On one side of the street of the campus, the Neurobehavioral Laboratory and Clinic, we recruit participants and either give them alcohol in the lab and collect blood samples, or monitor alcohol use outside the lab through transdermal alcohol monitoring and collect blood samples. On the other side of the street, the Biological Psychiatry Analytical Lab, we measure 3-phosphatidylethanol homologues, amongst many other types of things. But for this project, it's PEth-160181, PEth-160182, and PEth-160124. We're also performing various in vitro assays to study phosphatidylethanol synthesis and elimination as well. I'm sort of the bridge between the behavioral labs and the analytical labs. So the focus of my talk today is the extraction of phosphatidylethanol homologues using different solvents. So for the outline of my talk, first I will talk about a study in which we sought to compare levels of phosphatidylethanol obtained from liquid venous blood to that of capillary blood obtained by finger stick. The first study led me to be interested in the efficiency of different solvents to extract phosphatidylethanol. As part of a larger study that we published in 2018, we recruited 53 participants from San Antonio, Texas, aged 21 to 54, and they had to have one drinking episode within the last 30 days equal to the maximum study dose. Participants fasted overnight and came into the lab and had a catheter inserted into their arm. Venous blood was collected at baseline. Participant either received 0.4 or 0.8 grams ethanol per kilogram body weight. They consumed that within 15 minutes. Venous blood was collected frequently for up to 6 hours on alcohol administration day. For more details, please see the citation. For this study, capillary blood was also collected at 6 hours by finger stick onto blood spot cards. Liquid venous blood was stored at 4 degrees for up to 24 hours and then at -80 degrees. Capillary blood on spot cards was allowed to dry overnight at room temperature and then stored at -80 degrees with the desiccant pouch. PEth-160181 and PEth-160182 was quantified using high-pressure liquid chromatography and tandem mass spectroscopic detection. Here are the results. PEth-18-1, the correlation coefficient for venous blood versus capillary dried blood spots in male samples was 0.866, but for women it was 0.628. The slope of coefficients for men was 0.596, and that for women was 0.8. For PEth-160182, the correlation coefficient in male samples was 0.729, and in female samples it was 0.160. The slope of the coefficients for men was 0.729, and that for women was 0.281. So the correlation for men for both homologues was higher, but overall the correlations for women was poor. However, we extracted PEth from liquid venous blood using isopropanol followed by hexane, and that from capillary dried blood spots by methanol. So that led us to wonder, is there a difference in the efficiency of extraction solvents? So we decided to do an experiment comparing the efficiency of isopropanol followed by hexane, isopropanol, and methanol alone in liquid venous blood and venous blood spotted onto spot cards. We used a subset of blood samples collected in 2019 in Minneapolis by Brian Chen's research team, and he's at the Life Epigenetics Incorporated. And this was during our annual meeting on the Research Society of Alcoholism. Similar to our previous study, venous blood was collected, stored at 4 degrees for less than 24 hours, and then stored at minus 80 degrees until shipment overnight on dry ice to our biological psychiatry analytical lab. On the day of the liquid venous blood assay, samples were thawed on ice for 15 minutes. 50 microliters were pipetted onto each circle spot of a spot card and dried overnight. The PEth homologues 16-0-18-1, 16-0-18-2, and 16-0-24 were quantified by HPLC mass spec extracted by the various solvents and there were 4 punches of the venous blood dried blood spot. So here are the results. In liquid venous blood, the slope for PEth 16-0-18-1 when comparing extraction by isopropanol hexane to isopropanol alone was 1.729, indicating that higher calculated PEth values were obtained from isopropanol alone in this comparison. When comparing methanol to isopropanol, the slope was 0.936, indicating that slightly higher calculated PEth values were obtained from methanol, but were comparable to isopropanol. When comparing isopropanol hexane to methanol, the slope was 1.8, indicating that higher calculated PEth values were obtained from methanol. Similar observations were also observed for PEth 16-0-18-2 and PEth 16-0-24, but for the sake of brevity, I have not shown you this data. However, at the end of my slides, I have this data available if you would like to see them. So the results for venous blood in dry blood spots, the slope for 18-1 when comparing extraction by isopropanol hexane to isopropanol alone was 0.8, indicating that higher calculated PEth values were obtained from isopropanol hexane in this comparison. When comparing methanol to isopropanol, the slope was 1.6. indicating that higher calculated PEth values were obtained from isopropanol compared to methanol. When comparing isopropanol hexane to methanol, the slope was 0.5, indicating that higher calculated PEth values were obtained from isopropanol hexane. Again, similar observations were observed for the other 2 homologues. So in summary, in liquid venous blood, IPA and methanol resulted in higher calculated PEth levels than isopropanol hexane. And venous dried blood spots, isopropanol hexane and IPA resulted in higher calculated PEth levels than methanol. We currently use methanol for dried blood spots to be consistent with other labs here in the US. And we use IPA for our liquid venous blood just extractions. So I'd like to acknowledge this was several people involved in our group as well as in this study. So the funding that supported this study and all the faculty and staff that supported this study are in bold. Thank you very much, and I would like to accept any questions you might have.